Hello, this is a training video discussing the new options in the quality card system. So what you see here on the screen right now is just a data file that was given to us from one of our customers, and it's a typical single ramp, single soak type run. And I'm going to go over to the quality card editing screen. So we're going to go to reports, we're going to go to edit cards, and this specific data file is linked to the test card right here, and you can see that that's the recipe match right there. And what I wanted to go through is talk about the new features that have been added to the quality card system. There are some individual properties on the quality card and phase sections, and there's also a new calculation feature down here. So basically,
please call the operator. Ben, please call the operator.
Basically, the first thing I want to talk about are a couple of new options. One is over here. It's under the global analysis and the settings for this card, and you'll see that there are two check boxes. One that says show positive pressure analysis, and one that says show alarms at the bottom of the report. So in a typical quality report, and you'll see it here, at the very beginning there is a positive pressure analysis section right here, and then there's also, it ends with displaying all the alarms. Well, you can now suppress those by turning that to false, so the positive pressure analysis won't show up. So if I come back to this card, deselect both of these, come back out, and you'll see that those will no longer be there. There's no pressure analysis and there's no alarms. So that's the first thing. And one thing that you will realize that has changed is when you edit a card now and you come back out, the system will automatically select the quality batch report and show the results of that card to you immediately. So you don't have to actually select the quality card on the pull down. The next feature that I want to talk about is the phase changes. So basically, a phase, as the initial quality card system created, each phase was linked to its next phase, so that the first phase starts at the first data interval in the data file, and then when you end up with a phase change on in this sequential operation, it would then move on to the next phase, on the next phase, on the next phase. What I did is kept that same sequential phase capability, but I've added a parallel phase capabilities. So you can define a phase as being run in parallel to other phases. Therefore, if you don't want one phase to follow another, you can set them all up as parallel, and then at that point, with the parallel operations, you can tell the phase when to start and when to end using a specific criteria. So in the case of this specific phase, I'm calling that maximum air temp during run, and I'm selecting that as a parallel phase, and in parallel phase operations start and end, I'm leaving those blank. And so what it's going to do is it's going to analyze the entire data file. So it's going to start at the beginning of the data file and go to the very end and analyze everything in there. In this case, pressure during cure, I've identified that as a parallel phase, but in this case I'm calling out specific criteria that indicate the start of the phase and the end of the phase. So the specific criteria on start is low TC greater than 340. So the minute low TC hits greater than 340, it's going to begin analyzing each interval, and it's going to end when segment equals 6. So now the criteria can also include ands. So I can put and pressure greater than 30, 25, or something like that. So you've got full capability of putting whatever criteria that you want in there. Now that will define the start and the end of that phase, and so as we run down here, you'll see different parallel phases. It can either be blank on the start and end, or can have an actual criteria. But it's important to note that when you select a parallel style, the phase change on criteria and phase change delay are not programmable. So these will be blanked out, and you'll be dealing only with the parallel phase operations down here. Okay. So that's pretty nice, because what it can do now is you can jump around. You can have one phase look at a certain part of the run, another phase look at another area of the run, and they don't have to be interlinked, which is a very nice feature. And a similar feature is available in the data buy-off objects. So this just brings the data buy-off capability and features over to the quality card system. The next change that's been made is a small one, but it involves the part temperature analysis in the phase. So there is a new control by option, high TC only and low TC only, which can be selected. And what that will do is treat the entire part temperature analysis looking only at the high TC input or the low TC input, and it will not look at individual part TCs. That's useful if a customer says, we only care about the high TC and what it's doing, or the low TC and what it's doing. So that can now be selected. The largest change to this new system is the custom calculation analysis, and basically what this is gives you the ability of, as opposed to these fixed analysis groups, pressure analysis and phase, air temperature, vacuum, part temperature, you can now program your own custom analysis, which looks at a specific input or a calculated, a specific calculation, and will buy off on that calculation. And so this provides maximum flexibility. Really, you can look at any input, any series of inputs, any type of calculation, and buy off on that result. And so it makes it very, very flexible for those customers who want specific things analyzed. So as an example, I'm going to look at some examples here. So maximum air temperature during a run. Normally what we would do is we would use the air temperature analysis in the phase for that, but what I've done instead is I've added a specific calculation object called a maximum air temperature calculation name, and I've chosen that to be analyzing let's see, maximum air temperature during run. I'm going to say analyze all. So basically what it's going to do is within the phase start to end duration, it's going to be analyzing every data point, analyze all, and I'm going to analyze air TC, and I'm going to look at the maximum, have it analyze maximum value of that air TC and give it an alarm limit of 355. And so by doing that, I've duplicated what the normal air temperature analysis in the phase would be. And what we see, if we back out of here and we take a look at our quality report, you'll see that here's that phase analysis. And what you'll notice right off the bat is there is not an index number in front of the phase. If it's a sequential phase, it will be listed as 1, 2, 3, 4. If it's a parallel phase, it'll just show the phase title. And here you'll see max value was at 358 degrees at 93 minutes, and that was greater than 355. So what we've done is created a custom analysis. If we go back into our card, the other thing you'll see is you do have to enter units, because depending if this is a true calculation, the system won't know really what units you want to display. Okay. Pressure during cure. But here's one where we're looking at pressure and having a min max, and again that's occurring when the low TC gets greater than 340 and the phase ends at segment 6. So this is looking at just the cure segment, and it's analyzing the pressure during the cure segment. So if we look at that, we'll see that is displaying 29.9 psi at 165 and 29.7 at 126, both within tolerance. Okay. It's important to note that any deviation here, any out of tolerance, will be listed on the exceptions report, and so we can look at the exceptions report, and it's only going to list the exceptions to that quality report. So So if I go back to the batch report, now air temperature during rate, this one here is using the rate analysis of that calculation. So in this case, I'm looking at during cooling. So I'm starting when segment equals 6, which is the cooling segment, and I'm ending when RTC is less than 150. So it's has a specific start and end. I'm calling out a calculation called air temperature rate. I'm analyzing all points within that phase, and then I'm identifying RTC, and then looking at a minimum rate, maximum rate. Now, for each calculation, you can define a different rate calc interval and an advance. So a rate calc interval would normally be equal. If this is blank, it will use the card's rate calc interval, and basically the rate calc interval is how many intervals back is it going to calculate a rate over. Rate calc advance can also be identified per calculation, and so the rate calc advance says at the beginning of my phase, the first interval that I reach, how many intervals should I go before I start my rate calculation. And so this is useful, especially in this type of thing, cooling rate, where the first interval that will be identified within the cooling segment might have a 0 rate because we actually haven't started cooling. So we can advance that interval 1, 2, 3 intervals past, and then take a rate from there. And so we're identifying this as an advanced 3 intervals, and then do a rate calc interval back, which basically forces the system to use rate intervals or intervals within the actual phase. Okay, and what that looks like is if we come back in and look at our maximum air temperature rate, you'll see air temperature rate, max rate, min rate, and it identifies it just like a normal analysis. Okay. TC spread during run. This one's a little bit different. This actually, I'm looking for the spread between high and low TC, and it's parallel. I'm looking at the entire run. Start criteria, end criteria are blank, and then in this case, I'm using an actual calculation: high TC minus low TC. I'm telling it that it's in degrees F, and I'm saying, hey, I don't want that to be more than 20. So this calculation, you can have lots of. You can use parentheses. You can and it together. You can do greater. You can multiply. You can use absolute value if you want. A lot of different calculation features. We're just using high TC minus low TC, and then come back out, and we'll see that is now showing spread analysis. 24.9 is the maximum spread. And pressure at end of cure. This one's a little bit more involved. So I'm looking at this is really looking at a situation where I'm starting in my. This is looking at my cure phase. So low TC greater than 340, and it ends at segment equals 6. So that's in the actual soak segment, and I'm saying. I'm calling that calculation pressure and air TC in range. Now this is a little different. This is now going to calculate a true-false value based on specific criteria. So I'm saying pressure is greater than 25 and pressure is less than 35 and air TC greater than 345. Okay, so all of those will result in a true or false value. And in this case, because it's a true and false value, I don't really need the min value, max value don't really apply, but what would apply is a pass criteria. So I'm going to call it, hey, if this is true, then that quality phase has passed. Okay, if it's false, then it would be a failure. Okay, so if we look at that one at pressure at end of cure, we can come back out and we'll see that pressure at end of cure, it says pressure and air TC in range, pass, value equals true, and the true criterion is true. So again, we've got the ability to do minimum, maximum rate values, minimum, maximum rates, and also a pass-fail criteria based on whatever calculation this is. Okay, and this one, air to part spread, this is actually analysis that is looking at the difference between air TC and high TC, but because it's calculating over the entire run, I'm going to grab the absolute value of that. And so what this is going to do is use the absolute value function. And I've got a minimum of 0 and a maximum of 20. We come back out and take a look at our thing, and sure enough, it's calculating 47.9 at 195 minutes and 0.4 at 180 minutes. So those are all the type of calculations. Now, there are cases where this calculation is not enough, and you want to actually do a much more elaborate calculation. And for that, we can add a specific feature which allows you to use scripting and calculated variables. Okay, and the way this works is I'm gonna create a new phase called calculation script calculation. Okay, and you can name it whatever you want. And I'm going to add a new calculation. So this will be a parallel as well. Parallel, and I'm going to calculate over all phase start and end over the entire run. And I'm going to add a custom calculation. And what I'm going to do is I'm going to look at maximum of the maximum value of the low probe. Okay, max of low probe. Now that's pretty specific. I want to, or actually let's do maximum of. Well, yeah, that's fine. Maximum of low probe. Well, normally the way we would do it is we would just put low PRB here, and then put max value. But I want to show you how you can do that in scripting as well. So here in scripting, because script is a server-side function, and the data analysis and quality card is a client side, we have to expose the client variables over to the server. And so the way we want to do this is over on the right side, you've got calculation variables, and I'm going to add a couple of calculation variables. One I'm going to call it low probe. Okay. Now what this will do, if I create a variable that matches one of the inputs, then as it scans through each interval to interval, the quality card system will pull that value out of the data file and put it into this variable so that the script has something to look at. Okay, and then I'm going to add another variable called max of low probe. Okay, or I can just call it max. Okay. Now, why do I have two of these? Well, because I'm going to look at the low probe in my scripting, and I'm going to determine what the max value is using a max variable. So I'm going to compare the low probe with the max. The other thing I want to add is when I do find the max, I want to record the time or the run time where that max occurred. So here I'm going to say max time. Okay. Now you've got two scripts available to you. So if I want to run those scripts during the calculation, I can click here. The first script is a before calculate script, and what we want to do here is just basically initialize max and max time. So I'm going to go into that edit before calculation script, and here you want to use the me alias dot, and you're going to find those variables on the pull up. So max value equals 0 and me dot max time backslash value equals 0. So that's an initialization script for that specific calculation. And now the after interval script, which is going to be run every single interval, what will happen is the client will take the after interval script, send it to the server, have the server calculate it, and then the client can utilize the variables that have been the result of that. Okay, so I'm going to come into edit after interval script, and I'm going to say if me dot low pressure probe dot value is greater than me dot max value, then me.max backslash value equals me.lowProbe backslash value, and I'm going to also record the time. Now the time happens to be part of the feature is the time will be actually be a property of the calculation object. So I can just say me backslash, and there's a runtime property of that calculation object, so that the quality card system will update that runtime on that object so that the script can use it. Okay, so this will basically occur at every interval as it scans, and so basically that's the extent of this. And I'm going to change the name of this phase and call it low probe analysis using variables. Okay. So let's kick out now. When I back out of this, you're going to notice that it takes longer to run the quality card report, because what it's actually doing is for every interval it's running a script. It's running a script. So if you have 200 intervals, it's going to run 200 scripts, and that takes a little bit of time. So I'm going to back out of this and take a look at my, oops, something didn't work correctly here. Let's see what I did here. Okay, the one thing I forgot to do is I've created the variables. Now I need to tell the calculation what to look at. And here, instead of looking at an input value or a calculation using input values, I'm just going to look at, I'm going to put max here, and the system will know that is one of the variables that I'm interested in. Okay, so that's going to be in inches hg, and I'm looking at the maximum value being 0. Okay, so basically it's looking at the high probe, low probe. And the other thing that you want to so basically actually I don't really need max time because it should find it anyway. Oh, actually, let's talk about this. The very last that script is going to run during every interval. However, I don't want to actually compare this. I do the actual calculation until I get to the very end of my phase, and so there's a checkbox I want to mark that says calculate at last interval only, because what it's going to do is the script is going to build up max or evaluate max all the way through, and then at the very last interval I want to run this calculation, at which point I'm going to look at the comparison. Okay, and we'll see how that works. Okay, so it found a 0 Hg at 268 minutes. So let's see, and you can see the maximum was 0. Let's add minimum. Okay, and we can say me dot minimum backslash value equals 0 for the initialization, and we can then after interval say if low probe is less than min, then min equals low probe. Okay. So again, I can expose as many of these variables as possible, and then I just have to look at those. So here I'm going to say min is what I'm interested in looking at, and the minimum value is minus 30. Okay, and we'll come back here, a little bit more calculation time, and now you've got, you'll say, now what we're doing here is, because we're looking at a specific, I shouldn't analyze max of that. So because min is going to be the minimum value, I just have to use minimum value here as the criteria. Okay. Now Now, if I'm interested in knowing or putting a pass-fail on that, instead of using minimum value here, I could say if it's less than 30 for pass-fail, and now what you'll see is it will show it as a pass-fail. It says pass value is minus 26, and the requirement is less than 30. So here we're not using a min-max anymore. We're evaluating the actual value. Okay. And let's see. There is another thing. If you look at this pass thing, you'll see that there's no time associated with that because we're not actually identifying where that occurred in the script, and that's where we can utilize the time here. So I'm going to change this to time. Okay, and I'm going to reset that time here so I'm just going to call it time. And in after script, instead of looking at the time in the maximum one, I'm going to say me.time / value equals me / runtime. Okay. So what we're going to do in the script is we're going to record the minimum for each interval, or the minimum all the way through, and then the time is going to be the runtime at which point the minimum was reached. And what you can tell the pass-fail criteria is which variable to use for the time. And I'm just going to put time here. You'll see here, and the result of that will be that you can show. So it identifies at 2 minutes. So what we've done is told it within the scripting. Now we're using multiple scripts to determine what the minimum value of a specific thing is, and then we're then identifying where the time is where that occurred. Okay, so oops, I keep doing that. So basically, those are the new features. You've got the parallel processing of the phases. You've got the ability to do calculated analysis using a calculation, and then if you need something very advanced, you can expose specific inputs to scripting, and then write scripts that can then create a specific result variable, which can then be analyzed using the calculation and give it either a pass-fail or a min-max. Okay. So that's where we are. A lot of new nice features, and thanks for listening.